I can see a chord here. For what we have done earlier, I will not explain into details like before. I have seen a chord. Now, there's this angle, angle A. Can you see that angle? It's subtended by that chord. It's subtended by this chord. Now, there's an angle B also subtended by the same chord. But the difference between this one and the first property is that angle A ends at the center of the circle, center O. Normally, when center is labeled, you can consider center. Or the examiner will tell you center O. He will tell you that center O, or he will label it for you. Take note. So you have to read the preamble, the statement on top of the question or under it before you take action. If he doesn't label it and he doesn't state it in the question, don't assume for it to be a diameter or a center. So wait for him to state it or wait for him to label it. Then see it as a center. Now, so angle A ending at the center, angle B ending at the circumference. What do I mean? We started a 100-meter race. Usain Bolt, because of the energy he has, he finished it. So he has finished 100 meters. This one is not me. I won't do that. You, the person listening to me, watching me, you decided to end at 50 meters. You didn't finish. You were tired. Maybe you ate pepper before you started the race. So you ended at the center. So is it not principle that you have done half of the journey? Yes. And Usain Bolt has finished. Therefore, one of the angles is half of the other. True or false? Yes. Simple. This is simple logic, everyday business. But watch. If this angle, that angle A, is 20 degrees, what do you expect the angle B to be? I'm asking you this question. Answer me. I can hear you. You answer. Don't worry. What will be the angle? I'm not sure you say 40. Look at it critically. Now, in everyday life, let's use this. This is a tower. The triangle built there is like a tower. You know, if you are building a tower, because they are not parallel, they will surely meet at the apex. Can you see that they are meeting at the apex here, at the point, the top? They've met here. Yes, they've met. So the higher you go, so you can do it the way I've done my hand. Can you see? I'm building a tower, a triangular tower. The higher you go, then the closer they become. Right? The closer they become. So let's assume that my hand here be the middle. The middle here is the 50% and the top there is the 100%. So I'm asking you again, which one is bigger? Is it the center angle which is bigger or the top angle which is bigger? Surely the center. Can you see? So the center is always twice of the top and the top is always half of the center. So when you're given one, you apply this principle. So if the center angle is 20, then the top angle, which is B, angle B, must be 10 degrees. It makes sense. Building a tower, it makes sense. So I can say angle B is half of angle A. The examiner can ask you, what's the relationship between A and B? When the examiner asks you for a relationship between two things, write an equation for him. That's the answer. Don't write essay. He's not asking you to write essay. Paragraph 1, paragraph 2, introduction, conclusion. No. He wants you to write a simple equation. So I say, what's the relationship between A and B? You can write B is half of A, or A is twice of B, which we have just described over here. That's the relationship. Finished. That's your answer. But objective, he will choose the one he wants to present. You can write the top one or the down one, and either of them is correct answer. Thank you. Have you gotten it? Beautiful. Let's go to the next property. So we are still on the chord. Yes, we are still on chord, right? We are still on property of chord, and you are seeing how they work. What this one, this marks, what do they stand for? These two marks, can you see? It means those lines are equal and they are chord. Can you see? They are chords. So the first one, the first property was about the same chord. This now is about equal chords. It's not the same one, but equal chords. They have similar principles. Now, this angle, angle B, formed at the circumference is subtended by this chord, the first one. And this angle at the right hand side here is also subtended by another chord, which is equal to the first chord. Therefore, what do you expect the angles to be? Equal. That's why they are labeled the same variable. Do you get it? So, unless otherwise stated by the examiner, equal chords are labeled with the same variable. If it's x, x. If it's y, y is b, b. That's why you see that way. So, what do we say? Equal chords or angles subtended at the circumference or the center of a circle by equal chords are equal. The name even tells you. So what? The one at the center, this A, that's A. They are equal because they are coming from equal chords. Can you see? Can you see that these two lines are parallel? This vertical line, they are at par. That is what make the principle what makes sense. So no wahala over here. You've agreed. Good. Let's move to the next. Okay, now we are on center or diameter or radius. The moment center comes in circuit theorem, think of 90 degrees. Take note. I'm giving you a pop. When you hear of center or you recognize center in circuit theorem, think of 90 degrees somewhere. Now, this is a diameter, as you know. That's why it's labeled, right? O, center O. Any angle formed at the circumference of a circle subtended by a diameter is 90 degrees. So if I draw another one here, I'm using the same diameter, therefore here must also be 90 degrees. I draw a third one here. Good. Therefore, this must also be 90 degrees. It's the drawing that is making one bigger than the other. But by principle, they are subtended by the same diameter that's coming from center, and for that matter, 90 degrees at the circumference. Are you okay? So if I form it at the opposite side here, it's still 90. Do you get it? And this will bring the principle of cyclic quadrilateral. We look at it very soon. This 90 plus the opposite 90 must give you what? 180. You get a picture? Yes, 90 plus 90. So based on this, there's another property we are going to apply very soon. Cyclic quadrilateral. We look at it. So 90 plus 90 must give 180. Therefore, this angle plus that angle must also give you what? The same 180. Good. Let's move on to the next property. Good. We have seen another diameter here. So think of what number? 90 degrees. This is the center. The angle is passing, the line is passing through that, so diameter. Now, when a diameter makes an angle with a tangent, and this is the tangent I was referring to, this is the point. A tangent is a line that touches the circumference of a circle at a point. At a point. So, the intersection of a diameter or a radius, the mere fact that is coming from center is what matters. The intersection or the meeting point of a diameter and a tangent making an angle, that angle is equal to 90 degrees. Therefore, here is also equal to what? 90 degrees. Yes. So, the angle formed by the intersection of a radius or a diameter and a tangent is equal to 90 degrees at the circumference of the circle. 90. So, diameter, center, think of 90 somewhere. Finish. Now, let's move on. Good. We have entered into diameter, tangent property now. And tangent property, it has some for diameter and some for chord. So we have seen the diameter one. A tangent meeting the diameter, the previous one, or radius, gives you 90 degrees at that. But a tangent making an angle with a chord at the circumference of the circle, that angle from here, from the tangent up to that chord, that angle is equal to the one alternate to it. So there's an angle inside this triangle here at this corner, right? There's an angle there. That angle is equal to angle B. Therefore, watch here. The tangent also plays a role here. This angle, angle A. So that angle